Okay, so this webinar today is titled Worth a Thousand Words, Why Data Should Be Visualized. And hi, everyone. My name is Monica. I'm a researcher at Chaos, where I mostly focus on analyzing trends and emerging technologies in the AEC industries. However, I'm also a trained designer with a background in media and entertainment. In today's presentation, we'll explore several key aspects of data visualization in design, focusing on how visualizations are crucial for making data actionable for a variety of stakeholders. While I'll be presenting several illustrative examples of this, the concepts we'll be discussing are really relevant across any data relating to design. So we'll mostly be talking about the importance of kind of data visualization and design. The modern design process is much more inclusive than ever before, involving multiple stakeholders throughout all steps of the process. So this is really critical to be able to present and communicate data in a way in which it'll be the most relevant and impactful to your audience, ultimately helping decision-making across the board. So let's start with a fundamental truth. Data alone doesn't change behavior. Emotions do. This might seem pretty counterintuitive, especially in fields like architecture and engineering, where we really pride ourselves on rational, data-driven decisions. But the reality is, human beings are emotional creatures, and how we feel really has an impact on how we process and act on information. In fact, several studies have found that 90% of decisions are made based on emotion rather than logic. And we can really see this when we think about kind of recent examples that many of us probably experienced, panic buying during the COVID-19 lockdowns. So despite data showing that supply chains were intact and the lockdown really wouldn't be for any substantial amount of time, there was no need to kind of hoard goods at the level at which people were buying things. And this was ultimately because of the emotional responses and anxiety people had that led to this kind of behavior of widespread stockpiling. And this example really illustrates how powerful emotions can be in driving our actions, even in the face of data that says otherwise. So now, knowing how impactful emotions are to making decisions, this is where we really like to introduce the power of storytelling. So stories have the unique ability to engage our emotions, and consequently, they also have the power to change minds and behaviors. So these examples here are just some examples of how fictional stories, were powerful enough to really enact real change. So if we look at one of these, Disney's Bambi, it's really a story that is 100% fiction. It features animals that can talk. However, it did lead to an increase in anti-hunting sentiments. So the story itself had no data really involved, but the story was impactful and powerful enough to connect with viewers emotionally, leading to a change in thinking and a change in behaviors. And these other examples are just as significant. They weren't just books or films, but they were catalysts for significant societal changes. So how do we harness the power of storytelling in architecture? How can we present our data and designs in a way that engages emotions and drives decision-making? In the world of architecture and design, we really need to think of ourselves not just as creators, but as guides. And as guides, a designer's role is really to communicate across all stakeholders to bring forward a successful project. We're not just presenting blueprints and floor plans and technical specifications, but we're telling the story of a building or a space. We're inspiring our clients and team members, bringing out the best work and decisions by engaging both their rational and emotional sides. However, being a good guide and communicator comes with its challenges, such as understanding the data ourselves. As designers, we're dealing with complex, nuanced information about nearly every aspect of the building. So we really have to be sure that we ourselves really understand what it is we are trying to communicate. We also have the challenge of combating cognitive bias. We all have preconceptions that can cloud our judgment, even when it comes to data, and it's really important to be aware of that as we go into this process. And lastly, making the best decisions. With so much information, how do we distill it down to make optimal choices and then present those choices and that data to our stakeholders? And the challenge really lies in making all of this comprehensive and engaging. How do we take the complex data, everything from energy efficiency metrics to cost analysis, and present it in a way that's not only understandable, but also compelling to our clients? And the key is storytelling. And it's not just pure fiction or oversimplification of data. Instead, our goal should be to take the data and make it engaging by knowing our audience and translating the information in a way that is understandable and usable. So as designers, we should focus on telling a story with our data and speaking in the right language with the right information for each stakeholder. At Chaos, we understand the power of storytelling across multiple industries. We serve various sectors, and this diverse experience really gives us unique insights into how different fields approach storytelling and data visualization. And we really do know stories. Chaos has a rich and continuing history in visual effects and film. That's really how the company started. And those industries are all about telling compelling stories. While in architecture, engineering, and construction, you might not be trying to create the next superhero blockbuster film, you are in fact trying to engage your stakeholders in a similar way. You want your designs to resonate and to tell a story that captures imagination and drives decision making. And all of those are really kind of key. And we can take inspiration from what we know about the VFX industry and storytelling and apply that to architecture. The stories that we tell in the AEC industry are ones that are grounded in complex information. Each key stakeholder really needs to see something a little bit different in order to make the best decisions. So using this analogy of a tree to understand how different stakeholders interact with the design throughout the process. So the leaves really represent the client. They need information that's simple, nuanced, and easy to understand. It needs to be both visual and emotional. Clients can sway with the breeze of ideas and possibilities, and ultimately, they care about how the building looks and feels. The roots represent the engineers and contractors. They deal with the complex systems that support the entire project, focusing on rational, logical, and numerical data, ensuring the building is structurally sound and efficient. And lastly, the trunk represents the architect. We bridge the communication gap, translating between the client's vision and the technical realities, meeting project requirements while fulfilling the client's vision. As architects and designers, our job is to tell stories that are grounded in the complex information we receive from engineers and contractors, but also tailored to each audience member so that they can make informed decisions. So let's put this into practice. Here are some images that show a typical way in which we may present 3 different material options. These images really only communicate one aspect, the visual look of each. Is there a way in which we can fold data into these images in a way that'll lead to the most informed sound decision? It's really what we're going to be talking about today. But the trick is to really understand that who we are presenting to matters. Everyone will understand things differently. Just like musicians can look at a sheet of music and hear the song, or a sculptor can look at a mound of clay and see a work of art. And for many here, CAD software is really our professional language. We can look at a 2D representation of a building on a screen and be able to understand how it'll look once it's constructed in the physical world. But for our clients, this is really the world they occupy, the finished space, what you would experience if you look around where you're currently sitting. 3D spaces and visualizations of 3D space is really how clients understand and process the world around them. So with that in mind, as architects, we really need to develop a common means of communication. How do we create a common language for everybody instead of constantly needing to retranslate information for different stakeholders? It's crucial to recognize that design professionals and stakeholders, including clients, are two separate groups with distinctly different communication needs. Understanding this difference is key to effective communication throughout the design process. For design professionals, detailed plan drawings like this are often ideal. They provide the technical information we need to understand and work on a project. But this really isn't the best way to communicate with all our stakeholders, clients especially, who aren't used to seeing buildings represented like this. As we can see from this 3D rendered animation, this format can be ideal for communication with both design professionals and clients. This video provides a visual representation that's easier for non-professionals to understand. However, what works best for design professionals may not be the best for engineers or other stakeholders. Each group really has its own perspective and information needs. So looking at the plan drawing next to the animation, they both are of the same building. We have to ask ourselves, what works best for which audience? And the truth is, there really isn't one perfect way to communicate with everyone. So what we have to now figure out is what is the best way to communicate to the widest audience in a way that everyone can understand. And the answer lies in combining those very simple to understand design visualizations with data. But before we explore that further, let's consider what happens when we design without data. So these images represents design without data, unfettered imagination producing striking visuals. These images certainly are engaging, but while they may be aesthetically pleasing, they may also be completely unbuildable. And this is creativity without constraints, without any kind of data involved. And that's really why data is so crucial. It serves as an important reality check on creativity. Data grounds our designs in what's actually possible and practical, which is an absolute necessity for designing for the physical world. So let's take a look at how data can impact the design process. Here we can see how uncertainty decreases as we move through the design process. However, when we start using data early in the process, that level of uncertainty starts lower. As we introduce more data, we can significantly reduce the amount of uncertainty until we have a completed project. And, using this approach can actually make the process faster and more streamlined. And by incorporating kind of data, we can reach alignment between design intent and what is actually created, leading to a client and a team that's confident in the building they create. And in this talk, we're really going to be considering two main components. Design, where we're concerned with communicating aesthetic intent, and construction, where we're focused on constructing a physical building that follows the design intent. So in this next section, we'll be showing some examples of accessible data points that have high impacts on design that can be integrated with visualizations. I'll be focusing on operational impacts, embodied carbon, cost, and sequencing. While there are certainly more data points we could consider, these four will just serve as our illustrative examples for this webinar. When we combine data with visualizations early in the design process, we can make better informed decisions. This leads to reduced uncertainty and greater alignment between what's designed and what's ultimately built. In the design phase, we're primarily concerned with aesthetics, but we also need to consider other data like operational impacts, cost, and embodied carbon. When we move to construction, our focus shifts more towards sequencing and identifying responsible parties for each aspect of the build. But starting with the design phase, let's think about what data do we need to make informed decisions. Each of these elements, operational impacts, cost, and embodied carbons, will play a crucial role in the overall success of a project. So starting, let's look at operational impacts. So traditionally, energy modeling has been a separate process from design visualization. And the current workflow presents a challenge. Building performance modeling and analysis are often detached from the design process. It's not just about visualizing these things together, but rather about creating a workflow that combines the two so that the process can be better understood and integrated. Here, we can see the typical current building performance workflow. As you can see, it's a disconnected process with several friction points and opportunities for data loss. One such example, your building performance analysis results may be delivered to you in the form of a PDF. However, included in that PDF is data that will then need to be manually incorporated back into the design using 3D modeling software or CAD platforms. This creates opportunities for miscommunication and inefficiencies. With the beta release of Enscape Impact, which is available today, we really set out to simplify and improve that workflow, bringing it earlier and more integrated with the design process. So this approach has a lot less information loss and creates a more seamless integration between performance analysis and design. So we really condensed building performance into that visualization design process so that that data is no longer detached, but it's rather integrated directly into the process. But now that we have this data, how do we show it? How do we communicate it? Here we see some traditional ways of showing and visualizing building performance analysis. Lots of charts, graphs, and tables of data that are highly complex and technical. Why this type of data might be compelling and engaging for engineers, is it really the best way to communicate with clients or other stakeholders who maybe don't have a background in building performance? So this is a demo of Enscape Impact. It's integrated directly into Enscape. You need 3 very simple pieces of information to get an analysis. Now, what's very great about this is it's integrated directly into Enscape. So you have the data generated right there. And then since it is the Enscape plugin with your CAD platform, you can actually see and view changes to this data in real time. So you can actually make changes to your building. Here we're changing some material options, and you can actually see that the data on the toolbar over there updates with this new information, and it updates in real time. And because we wanted this to not just be data points, we wanted it to be something you could actually show to a client and so that they could actually understand the impacts of the building performance and the design decisions. We did integrate a way to view those results integrated within the renderer. So you can actually interact with this in real time. You can take clients through, you can generate kind of renders, and you'll be able to share that information and visualize that data. So now let's try embodied carbon, which is another crucial factor in the design process. Embodied carbon is becoming increasingly important in our industry, but it's difficult to effectively communicate its impacts. Similar to what we just previously saw, we face a communication challenge. Traditional ways of showing embodied carbon often involve complex charts, graphs, and tables. While these are very informative, they're not always appropriate for communicating with a broad audience. So here's one experiment in presenting carbon data in the context of design. So on one side, we have a render of the building alongside a simple chart showing global warming potential and carbon figures. This is a step in the right direction, but let's try something even more imaginative and intuitive using tools from Chaos. So in this visualization, you can see the exterior of the building really morphing in relation to its carbon footprint. The building distorts more dramatically depending on the amount of carbon. This type of communication is no longer just about the actual design and how it looks, but rather becomes the medium for communicating carbon effects in a very visceral way. So here is a side-by-side comparison. The visual impact of the increasing carbon footprint is very dramatic and very memorable. The building's form becomes increasingly distorted, providing an immediate, intuitive understanding of the environmental impact. And when you make changes, you can see how the animation becomes different. Okay. In this side-by-side comparison, you can see that the exterior of this building, after we change the material, morphs even more and becomes even more distorted. And in this final example, we can see just how far you can push these animations to communicate the impacts of carbon. So again, in this side-by-side comparison, you can really see just how dramatic of a change these animations and visualizations can be. By putting these animations together in such a memorable way, in conjunction with the data, we create something that's potentially more impactful and helpful to decision-making. This engages both the rational and emotional sides of our stakeholders, making the concept of a carbon footprint not only tangible, but also urgent and more easily understood. Now that we've explored operational impacts and embodied carbon, let's turn our attention to another critical factor in any design project: cost. While cost is undeniably an important consideration in any project, it should never be viewed in isolation. As we can see from this diagram, cost is just one part of a complex web of connected factors that ultimately influence our designs. So here we can see everything all together. These are examples of how our data visualizations may look to a client faced with a decision. The critical data is all shown in the context of the 3D space, maintaining our focus on aesthetics, but adding in crucial information in an easy to understand and holistic way, facilitating more informed decision-making. So now let's shift our focus to the construction phase, particularly sequencing and responsible parties. These elements are crucial for turning our designs into reality. And it's important to note that while we've covered several key areas, these are all just examples. There are many other factors to consider, and moreover, there are significant differences in how this information is applied between design professionals and contractors. So really understanding these differences is key to communicating. So starting with sequencing. So a simple visualization like this can be easily understood by anyone in the trades, contractors and subcontractors alike. Seeing the project in its context makes it extremely easy to understand and to visualize what it'll be like on site. So what we've done here is we've just enhanced that previous image. Each piece of pipe or component is highlighted with a color showing the order of installation. This is just another powerful way to integrate data with visuals as opposed to just handing them a list or something like that. So making the construction kind of sequence intuitive and easy to understand for clients, for contractors, etc. And in this example, we can see how easy it is to integrate data about responsible parties. So again, we've just highlighted each object with a color. The legend on the side lists the responsible party for each element. And this is really a visual approach that's able to quickly communicate who's responsible for what, reducing confusion and potential conflicts on the job site. When it comes to construction, logistics are crucial. Understanding what equipment can fit where can make or break a project's timeline and budget. So in this example, we're exploring a model in 3D in a way that's easy for those on site can understand the context and what's going to be possible without even being present on the site physically. So presenting data and information in this way can really be helpful and can save countless hours and prevent costly mistakes on site. While we have many powerful tools currently at our disposal, there are still pieces missing. This presents both a challenge and an opportunity for further innovation of bringing data into visualizations. So what's next? At Chaos, we are constantly exploring alternative ways to tell stories and explore data through design visualization. One such way is our recent stylistic rendering feature, which renders your geometry as a pencil or pen sketch. So these styles are integrated directly into Enscape right in the visual settings, and they allow users to see their project in a different light. So you can easily just switch to kind of sketch mode. There's a couple different parameters you can adjust to ensure you're getting the effect that you're really looking for. This sketchy, less finalized look communicates to the client that the client is still in progress, as opposed to a photorealistic render that might appear more set in stone. It's a very subtle but powerful way to manage expectations and encourage feedback. And you don't have to do any additional work creating a render like this outside of just switching the visual style mode and then affecting some of the details. And since it is a feature of Enscape, you can actually interact with the model in this mode in real time. So if you wanted to do a walkthrough or show a client, what a building may look like without any textures or without any shading or shadows, this is a really great way to showcase that. And we're not stopping there. We're continuing to develop different kind of artistic render styles, including colored pencils and watercolor effects. These offer even more ways to tailor your visual storytelling to different audiences and stages of the design process. So this is a proof of concept to show where we're thinking of going and kind of next steps in terms of Enscape impact. So here, you're placing an appliance and you'll able to see the environmental impact of that appliance on the building performance, and those values adjust as you kind of place. We're also thinking about using generative AI to, for example, populate a scene depending on occupancy levels. So, for example, if you wanted to see 75% occupancy, it could populate entourage in that space, and then also use that information to generate building performance values or data associated with that occupancy level. And the real beauty of this approach is that you don't have to be an expert to use it. It really allows everyone involved in the project to make better decisions and communicate more effectively about complex performance issues. So, in closing, I want to emphasize that the power of data visualization really lies in the ability to bridge the gap between complex information and human understanding. By making data visual, interactive, and contextual, we can tell more compelling stories, we can really make better decisions, and ultimately create better informed designs. Thank you.